Week 0, our Introduction to Engineering Electromagnetics. This is just going to be a quick, brief intro video to everything that's going to be covered this week, as well as an introduction to the course and what to expect throughout your semester. This particular week, we're going to cover the textbook, some course strategies, the prerequisites which are required for the course, talking about what exactly is a Week 0, and some final remarks, some tips and hints I want to give you guys before courses start. So the textbook for the course is Engineering Electromagnetics. It's either going to be the 8th edition or there could be a 9th edition. This has been the book for a while now. You can get this through the bookstore or through Amazon. You are going to need the textbook. The other resource I recommend you get highly, it costs maybe $20 on Amazon, is the Shalm's outline for the mathematical handbook of formulas and tables. This is the one that I used when I personally took the course, and you can find other math handbooks or other brands, but this is just the one that I grabbed because it was cheapest, and I've actually used it in quite a few courses after EEMAGS, so it is a pretty important book to have. Let's talk a little bit about the course strategy and how to actually pass this course. First things first, no matter where you go, if you listen to some other universities' videos, they always mention this, and it's just so true with this topic. Do not fall behind. This course is extremely fast-paced, and it's known as one of the most conceptually challenging courses in the ECE curriculum. You really want to stay on top of your game, and to be able to do that, you want to enable yourself to read the book throughout the week. Reading the book before the lecture is a great practice to get yourself into. It allows you to see the material before it's covered in lecture and actually be able to ask questions without being stumbling over the basic core concepts. If you've never done this before for a course, this is definitely the first one to start doing it. Any notes that we give you, either through these video lectures or in class, it's very good to spend time outside of class to actually redo any derivations that we do that's done, and to put them in your own words. And the same thing with the notes too. It's just a good practice that you don't want to just mimic everything that the professor writes down. You want to put it into your own words. Put it in the ways that you understand it. One of the other core things to actually pass this course is to be able to get to a point where you can visualize what you're doing. So if you can actually figure out what the hell you're doing in a problem, you're a lot better off than just trying to read through an equation sheet on a test and figure out what one to use. If you can actually visualize what is going on, that's going to lead to a lot more success. Work together and studying together. If you haven't made study groups yet, do so. If you're not part of a study group, get part of a study group. Every week you should be meeting up with a couple of your friends or a study group and renting out a room in the library or in the dorm rooms and just sit down and crank through problems. Go through examples from the class. It's going to make your life so much easier. And the other one is, the other last point is do more than what is asked. This kind of just seems stereotypical. You guys should know this by now. You're in college, you're in engineering. You should do more than what's actually asked. But for homeworks, we're going to assign you some problems, some from the book, some custom made. But if you really want to pass this course and you really want to understand the content, you're going to have to do additional problems. And really the best way I could recommend studying for any of the tests is just doing the problems in the back of the chapters, all of them. So talk a little bit about the prerequisites and what we're expecting you to come into this course with. For math, you're going to need to know derivatives and integrals, so basic calc 1 and 2. Some multi-dimensional analysis, so multi-dimensional integrals and derivatives and surface integrals and contours and all that stuff. That's Calc 3. Differential equations, you're going to need a little bit of it, so if you either took ordinary differential equations or MEA 1, it's going to be covered there. Vector analysis, which should have been covered in Calculus 3, as well as linear algebra, and if you took a statics and dynamics course, it'll be covered there as well. In terms of physics, you're going to need some introduction to mechanics, just some of the basic concepts from there and the thought processes behind the actual laws that were told in that course. You're going to need to remember your intro to E&M, which was your Physics 2 course. This is basically going a lot more in depth into that and talking about the actual math behind it and its applications. And you're going to need statics and dynamics, which may have been covered in mechanical engineering for ECE, or in a statics and dynamics course if you actually took that in particular. And as for ECE specific courses, We recommend PECA, which is Principles of Electric Circuit Analysis, or an equivalent course, and our hybrid course called Modules, which covers a lot of different analysis techniques. So what exactly is this week 0? Traditionally in the course, the first week was reserved for teaching Chapter 1. Chapter 1 is essentially just a bunch of review. It's talking about a lot of topics that were in your prerequisites, and unfortunately this eats into the semester, which is already crammed with topics that we need to cover. Since all the content is essentially review, it was a decision to actually move this week's content online and make it a prerequisite before coming into the course. So that being said, all this material within week 0 is meant to be viewed and completed by the first day of classes. You are going to be held accountable for all this material and understanding what's going on. I highly recommend you take the time to do the problems throughout the chapter, so the discussion problems and the example problems in the book. It's just really pertinent that you understand, like really, really, really understand the material before classes actually start. So a little bit about Chapter 1, it's vector analysis, so things like dot product, cross product, coordinate systems, what actually is a vector. Just a good sequence to proceed in actually studying through this week 0 is to read the section in the textbook and take your own notes. So don't just highlight everything. Instead, read through the section, see what it says, take your own notes, and try the problems on your own, and then watch the lecture video, which is going to be online, and then supplement your own notes. If we mention something else, then you can write it down in your notes as a supplemental note. I'm going to try and provide some more resources if you need further help. So there are probably going to be videos on derivations or another way of explaining a concept, and some of them will be myself, some of them will be from other schools. But this is just to get you into the idea of, I can actually look other places for help as well. But we do recommend that you come to us with questions. Then after watching the lecture videos, we're going to have some problems that's going to be on the same webpage, or we'll put a link up. So do those problems and then compare answers to the videos that are online for actually solving those problems. Give yourself time to review notes, and if you need to, even textbooks from previous courses. There will be a set of homework problems which will be due by the first week of class. And there also is potential for a quiz on the material covered. Just some final remarks. This is just some hints from someone who's actually taken the course before and hearing people talking about what's worked for them, what hasn't worked for them. I can't stress this enough, and it's not going to get stressed enough in the course either. You really need to keep on top of your work. You really need to stay on top of it, even be ahead of the lectures, and just do the homeworks throughout the week. Don't wait to do the quizzes, study for quizzes. Don't wait to study for tests. Do it ahead of time. And actually do your own work. So you may be working together in groups, and you may actually find some solutions online to the book problems. I know that's a thing. I've been a student before, and I've looked them up. Just on the tests alone, and just by changing some numbers, or just changing a little bit of the conceptual background for a problem, it's going to be very easy for us to tell whether or not you actually understand the material, or if for the homework you either just worked together and copied it down. For equation sheets, this kind of extends to every class that you're going to take, and you may have heard this before, but you don't want to wait until the night before the test to actually make it. The best way that you could actually use your equation sheet is to start writing it up and then do some practice problems. So either go through the homework again, go through chapter problems, and only use your equation sheet. Don't open up the book. Don't use any online resources. If you can get through the problem using only that and what you know, then great. You have enough on your cheat sheet. If not, then you can figure out what you need to actually add. And I truly would account for actually blanking on the test, so make it as much information as possible. Don't skimp on it. And do your own research throughout the course. So as I mentioned before, if you're having trouble understanding a concept, please, ask us for questions, either your TA for the course or your instructor, but also do your own research. Look at other courses, things like MIT's OpenCourseWare, or if there's a Coursera course open, or definitely on YouTube, there's bound to be information, abundant information that people have actually made in the past. And what's good is that hearing that will actually give you another way of explaining it. which definitely helps in your comprehension of the material. But I'm just going to give you a forewarning. If you do go to other places, this isn't to discourage it, it's just a warning. The notations and symbols and variables sometimes can differ between different sources, so you really just need to pay attention to what they're saying, and I would recommend converting anything you find in those videos to any of the notation differences in those videos to what we use in our class. So otherwise, welcome to EEMAGS, and I wish you the best of luck.